Today, we're diving into a really powerful idea. What if we could actually unlock all the knowledge that's just sitting there, trapped inside the millions of documents we look at every single day?
I mean, really think about it. You've got scientific papers, patents, all these technical reports. They're just packed with brilliant ideas, right? But here's the catch. They're totally inert. They just sit there. On the page, on your screen, as a PDF that you can read, sure, but you can't do anything with it.
And this gets at what the source material for this explainer calls a structural gap. It's a great way to put it. We're great at communicating knowledge, but we can't really operate on it, you know? You can read about a new method, but you can't actually run it. You can see a cool new design, but there's no way to test it right from the document.
Okay, so take a new clinical study, for example. You can read the results, which is great, but you can't touch the actual patient data, right? Because of privacy. Or what about a NASA mission plan? I mean, how on earth do you stress test that for every single thing that could go wrong? In all these cases, the knowledge is right there, but it's completely locked away.
But what if that could change? What if you could press play on a research paper? What if reading a patent felt less like reading a legal document and more like opening up a simulator? This one simple question, what if, is really the key to a totally new way of thinking about knowledge.
And the solution hinges on this incredible concept called the latent simulator. Here's the core idea. Any well-structured document, whether it's a paper or a patent, isn't just a bunch of text. It's actually a blueprint. It's got all the pieces you need, the entities, the rules, the relationships, to build a real, working, interactive model of whatever it's describing.
And look, this isn't just some abstract, poetic idea. The technical monograph we're looking at today states it flat out. This is the central thesis, and it's the foundation for a framework called DBbun. And DBbun's whole mission is to make this concept a reality. Okay, so the big question is, how do you actually do that? How do you turn a boring old PDF into a working simulator? Well, the process is kind of like a knowledge assembly line. You feed a static document in one end, and step by step, it produces this dynamic, interactive environment out the other end.
So let's break down that assembly line. It's basically a 6-step pipeline. First, you ingest the document. You just feed it in. Next, the system gets to work extracting the structure. It's identifying all the key pieces, the variables, the rules. From there, it constructs a formal blueprint, what they call a schema. Then, and this is super important, it enforces constraints. You know, things like the laws of physics or mathematical rules to make sure the simulation is actually realistic. And finally, it generates the whole interactive environment and validates it to make sure it's good to go.
Now, what's really amazing here is just how powerful this one single pipeline is. It's totally domain-agnostic. It doesn't care what the subject is. The exact same 6 steps have been used on documents from more than 20 completely different fields. We're talking everything from aerospace and robotics all the way to urban planning and finance. It's wild. And the real-world examples are just wow. For instance, this framework was used to simulate astronaut performance for NASA's Artemis II moon mission. It helped explore 1,000 different drone designs for a DARPA challenge. In healthcare, it generated a synthetic dataset of 1 million patients to study insomnia, all from a single research paper, and with 0 privacy issues. And for finance, it built a huge graph of 500,000 crypto transactions to help spot money laundering.
Okay, but hang on, because this is where it gets really mind-bending. The system doesn't need a document that's already full of data. It can actually create data from a document that has no data in it at all. Seriously. Check this out, the LLM Education Simulator. The source for this wasn't a data report. It was a purely conceptual paper, basically an opinion piece about using AI in education. So the framework read the paper, extracted its arguments and the scenarios it described, and boom, it created a working simulator that generates real, structured data about how synthetic students might interact with an AI tutor. It literally turned pure ideas into data. That's the magic trick.
And you should know, this isn't just some fringe academic project. The whole thing is backed by 3 separate patent applications. They've basically codified the entire process. 1 patent for the core engine, 1 for the user interface, and 1 for the whole process of turning a document into a simulation. Okay, so at this point you might be thinking, wait, how is this different from other synthetic data tools I've heard of? And that's a great question. Here's the key difference. Traditional tools like GANs, they need real data to learn from. They're designed to mimic an existing dataset. This framework, it doesn't need any data to start. It pulls the logic straight from the text of the document. And that means it can create models for things that don't even exist yet, things that have never been built or studied before.
When you zoom out, the implication here is just massive. This isn't just a cool new tool or another piece of software. It's really a proposal for a whole new layer in how we communicate science and knowledge. Think about it. We've got the publication layer, the paper itself. We've got the data layer. This introduces a third layer, the executable layer, where you can actually play with the ideas themselves.
So why does all this matter? Well, for researchers, it means you can test theories way faster without waiting for real-world data. It could be a huge help in solving the reproducibility crisis because you can share the how, the method of your work, without having to share sensitive data. And if you're an innovator, it means you could explore a new invention from a patent the very same day it's published. It's a game changer. Ultimately, what we're talking about is technology that can transform static, boring information into living, breathing, explorable worlds. So the final question isn't just about what we can build, but what we can understand. If any document can become an interactive world, what will we discover next?